let's do this absolute velocity u. So then it will have x component of velocity, then y component. How this particular bob A will move? I think the string will not permit it to move along vertically, because the moment monkey jumps, what is the state of string? Will be taut, and string is inextensible. So what happened to velocity of block A along y-axis will be nullified. It will acquire only velocity along x-axis. So Vax, you write it. Mass of this is 2m. This is m. The mass of this is 2m. Okay, apply conservation of momentum along x-axis, you'll get the horizontal velocity of the monkey. So this monkey weapon will go and land. So when it is landing, it will have just before landing. So it will have same components, what all we, and this is at rest. Once it lands, this will acquire a momentum. Okay, no. I'll give small diagram, because so this string mass 2m and the monkey will be here. This will again, what is the possibility of this? This should acquire velocity only in this direction, no? Because the string will not permit to acquire velocity along y direction. Okay, what all equations we can write it on. So initially the monkey was at rest, so conservation of momentum mux 0 equal to mux minus 2m Vax. So what is Vax is equal to ux by 2. So theta is 45 degree. So this timing, let me write this one. Similarly, what is VBX? VBX should be equal to M ux should be equal to M plus 2M into VBX. So VBX is equal to ux by 3. So what is the condition again? What is VBX? It is just sufficient to complete vertical circle. This VBX, what all it's imparted. Problem is over. Nothing we have to. What is the probability of asking such questions? So definitely open the IT process do prefer such numericals where all small ideas, nothing big. What should be the VBX? Root 5 GL. So can we get UX now? So substituting this here. For why root 5 GL I should write? There's a minimum velocity required at lowest point to complete vertical circular path. So therefore this will be root 5 GL UX. So what is UX is equal to 3 root 5 GL. So if you know UX, then we'll get VAX also. Okay, this initial background, what all momentum, everything. Okay, let's come for this one. We have, so this angle theta is what? 45 degrees. That is given for us. So can we get the time of flight? T is equal to time of flight. So this time of flight should be equal to 2ui by g. At the same time, this d should be equal to ux into t. Ux is what? 3 root 5 GL. This is 2 uy by g. Any relation between ux and uy? Theta is 45
Equal.
degrees. That is equal. As theta equal 40 degree, ux equal to uy. 2 by g, and this is ux. So one more time. I think this 6 by this is g, ux is 3 root by g. 6 3 ja 18, 18 5 ja, nl
90L.
90, yeah. Yeah. 90 L d is equal to. Okay, now we got, so how to get that u? Still we are not at reached that u, no? What all is asking? Find the distance d between string and speed with which monkey jumped off the ball A. So the distance we got it, but we don't know that u still.
Root to UX.
Root 2 ux. Yeah, okay, fine. Yeah. So this u should be equal to u square equal to ux plus uy. Okay, this is the initial, the part A of the problem. Let's come to the find the impulse of the string tension on ball A during the small period when the monkey interact with the ball to jump off it. Will there be any impulse in the string, left string, or in the right string? We'll discuss for both, no problem. Why there be so many impulse will act, and will it stay or will it vanish? What actually goes on there? You look at this one, the moment monkey jumps, no, so this UI will be there. This particular thing. So an impulse will act. Suddenly, what when the tension in the string will increase, and it'll be nullified. So how much that impulse in the string? So the impulse in the left string, part B of the problem, impulse in the left string just after monkey jumps off. That should be equal to JT, I'll write it. That should be equal to mass of that one is 2m, no? So 2m muy only, I'll write it. Why I should not write anything? Because the particular, what is the momentum of that particular ball will try to acquire that momentum, but the string will nullify it. It should be equal to this much. Uy equal to ux, and ux we know it, so they should be equal to I think directly ux somewhere value
3 root
3
5G.
to root 5 here. So this will be 3, I'll send inside 945. So m equal to how will it continuously will act this impulse? What will happen to this impulse setup? So if you look at the diagram, so here the weight 2mg will be acting. The impulse what happen, maybe I don't know how it will increase something and will become again this that. What is delta t? Time taken by the monkey to lose contact from the sphere. In that interval of time, it will be how that variation occurs, we don't know. So the tension will increase, but immediately it will be nullified. The tension string will become greater than 2 mg, but it will be nullified. In JEE Advanced, they may test this thing because here, okay, mathematics we can bring. So just you have to think once. Just be alert. Some good ideas based questions are there. We'll take this one. So this will come and collide. Just before collision, I'm showing the diagram. Collide inelastically, add-on inelastic collision. Perfectly in between A and B is perfectly elastic. So that they'll be in contact. Let's have a diagram. Let's see what information we'll get it. Just before collision, this is A, this is B. It will have a speed U. What happened to that A and B? Will there be exchange of velocity? Perfect inelastic collision. Perfect inelastic collision means what should happen after impact? This A, this B, they must have same velocity. Then it will rebound. Okay, I'll do one thing. VBX, I'll write it. This will be VBY. I think this much is the major part of the problem. Just after impact, this is before impact, this is after impact. Then perfect inelastic collision. So masses are equal. So what is the equation we can write? Mu should be equal to mVAX plus mVBX. As a perfect inelastic collision, Vx should be equal to Vbx. So this should be equal to how much? U by 2. What is VBY? Should be equal to E into U. So this should be equal to E 0.5. And then what is the trajectory? The ball B overlapping is going to move in a parabolic path and will come here. And the ball A will just move. Okay, based on size, okay, they're going to, after what time the two balls will collide again. When ball is somewhere here, the ball will be somewhere here. Small idea-based problem, nothing big. So what is the time? What is the time? T equal to 0. This is T equal to T. What is the time of flight? The time of flight is given by 2 VBY by G. So this will be equal to U by G. Quotient of restitution is defined only for a pair of colliding surfaces. Pair, it is defined only for a pair, not like all these three, A, B, and ground. What is the quotient question? No, it's undefined. It's defined only for a pair of colliding surfaces between A, B, or between B and ground. This is something very, the basics of the collision one, where we are taking help of some mathematics to conclude things. I think this already you might have come across. But once have a idea of like this, because if you check the advanced paper. We don't have anything discussion on like this here. Let me give set of diagrams. So initially a ball is moving. A ball is moving with a velocity v naught, makes head-on collision with another identical ball, which is at rest. The velocity of incident ball and the other ball after collision is v1 and v2. Okay, let's apply conservation of momentum. So from conservation of momentum, mv naught equal to mv1 plus mv2. Okay, let me plot graph for v1 versus v2. So how it will be. So this will be the expression for v1. This will be v2. On what basis we can write like this here? v1 equal to minus v2 plus v naught. v1 equal to minus v2 plus v naught. If I plot it will be a straight line. If v2 0, v1 should be v naught. If v1 0, v2 should be v naught. Okay, this is the equation of straight line. Then, assuming the collisions to be elastic, write an equation for kinetic energy. Plot a graph of v1 versus v2 using this equation. He himself is helping us a lot. mv1 square by 2, mv2 square by 2. So this equation, so this will be like some sort of equation of circle. v1, this v2, this will be v naught. Let me superimpose these two graphs. The intersection of the slope of the above two graphs give the solution, find v1 and v2. Let me superimpose these two. Please, very important, those who have totally forgotten anything, please do revise. Huh? They'll help you a lot. You check the advance, we don't have any discussion much. We don't have anything about like this questions, that possibility of asking. I think not. I'll read a fresh one. Okay, this is a circle. Okay, this will be v1. This will be v2. The intersection of the above two graphs give the solution, find v1 by v2. I think there are two graphs are there. We have superimposed. So this should be the v naught value. This will be v naught. Okay, what is the interpretation you can make it? When v1 equal to 0, v2, I think that this is one point not possible, no? Okay, I'll start from here. There's an intersection point. So A, we'll take it. This is B. At A, at point A. At point A, what is the condition? V1 equal to V naught, V2 equals 0. At point B, V2 equal to V naught, V1 equal to 0. What are V1, V2? First of all, V1, V2 are velocities after collision. No? So what we can write it? No. Is this possible after collision? Not possible. So this is what possible here. So like this, what happened? The intersection point will give the speed of the colliding particles after collision. So I'll just shade it out. So this is not possible. Let me write it. Able to analyze? Just say it will go and collide and still it will have velocity V naught. How it is possible? Cannot happen. But it can happen, no? Where this will come to rest. This will have velocity of that of the block A or the first particle. It can happen. Agree this? Okay, now let's get into. So there's a first particle, there's a second particle. Okay, now the idea. So he has brought now a question for us. In a particular question, the plot of graphs mentioned above is as shown. What is the meaning of this? Find V1, V2 for this collision. Also write the percentage loss in contingency during collision. There's a part C of the problem. I will move it to the corner. Some of you. Okay, this is what the discussion. Not possible. Okay, no confusion. Someone is telling say what graph to which one. So now let's come for the graph D. The red color line. Okay, no. Okay, these are the points are there. Let me take A. This is B, and this is what is telling equal to 2. Coordinates of point A and B are given. Any relation between V1 plus V2? Shall we write V1 plus V2 equal to 2? Because that is what the initial velocity, what it says, no? Applying conservation of momentum. M final momentum is what it will be. Let the velocity of this be V1 and V2. The initial momentum is what? M2 or 2M. So applying conservation of linear momentum, or you do one thing if you're getting confusion, leave this, take out this circle. Account to this, again, go back. So what you write? What is this V naught? V naught should be equal to V1 plus V2. Don't get deviated. It's like this. So therefore so very first equation, what we can write? M into 2, it should be equal to MV1 plus MV2. Write it here. Now applying conservation of kinetic energy. m that eta is needed, no? Because we don't have the radius of circle, so therefore I'll proceed like this here. Mv naught square by 2 eta is equal to mv1 square by 2 mv2 square by 2. Why that eta is brought? Do we know radius of circle? So what is radius of circle? Will be eta v naught, root eta v naught. It will be, so therefore this will become eta v naught square equal to v1 square plus v2 square. This everything will become radius of circle. I'll write it r. What is r? R square will be eta v naught square. Can we calculate radius? Any information? I think for that they're given coordinate. So here you draw the line like this. Take help of anything. What all we know? We know this coordinates of this is 0 0.5, 1.5. So can we bring this r square is equal to let's get into the part. R square is equal to 0 0.5 whole square plus 1.5 whole square. That should be equal to eta v naught square. Anybody eta? Yeah, 0.625. Now, what is that 0.625? What is that eta? First of all, sir, you wrote something eta. Eta is what? Percentage loss in contingent. That is the like a factor by which contingent decreases. No? So 1 minus eta will be the into 100% will become percentage of the loss in contingent. Because the contingent will decrease. Sir, how you can see? If the curve is here, it will be elastic. If the curve got shifted here, then it will be inelastic. In elastic collision, the final contingent should be less than initial contingent. So how much it got decreased, that's what theta. So percentage loss, now we'll calculate. Percentage loss in contingent should be equal to 1 minus eta into 100. Then, but he is asking V1, V2. What can be the velocity of colliding particles after impact? Initial velocity is how much?
7.5, sir.
That is 7.5, no? 62.5. Yeah. 62.5. Okay, 25 will not come. Now, whatever the velocities of colliding particles, can V1, can it be equal to 2? What are the possibilities? Either V1 will be, let's go for possible velocities. V1 will be 0 0.5 or say 1.5. V2 will be 0 0.5. This is one thing. Next, other possible value of V1 will be 0 0.5. Now, which one is possible? How to check which one is possible? Is there any means or two values will come? If you solve this particular graph, no, there are two values are there. So that's what is given. This will be 1.5. Now, which one has to be picked up? Both are possible. Anybody wants to share? I think like previously we had a
Second one.
discussion.
Second one is possible.
This is possible. Huh? Why this is not possible?
Coefficient of restitution cannot be negative.
E should be equal to V2 minus V1 by initial velocity is 2. We have check that. Check that. The formula will be V2 minus V1 by initial velocity. This is what I think I'll write it U. So this will be 1.0.5. This is possible, no? E cannot be negative. Huh? 1/4. Yeah. Not possible, no? This is
1/2 only, sir.
1/2 only. Yeah? 1/2. This will be 0.5, 1/2. Okay, this is meaningless, no? Something. Okay, this curve plays very important idea, that one. It will tell us the nature of collision, the intersection of those points. And we can also calculate quotient of restitution also. That's what in the end I'm trying to conclude here. Last one, this problem will take it, then we'll wind up. Read the question carefully, that the small idea, the condition what he has put is very important for us. So what is the thing? The two blocks have been placed on a smooth table and the block C of mass M, which is very much less than M. I think this C is very important. Between A and B is L close to A, so I have to compress the spring attached to A by X naught. I'll give sequence of diagram. The rest everything you can manage very clearly. This is the block M. It is compressed so that here spring force kx naught will act, and the block B is still at rest. BAC. We'll just try to see what all conditions will exist. So spring force will act. So the spring force what will happen? Will act till where? Till when it attains natural length. So when it attains natural length, somewhere here, it is natural. I'll spring is relaxed. So this will acquire velocity, say V naught. This will acquire velocity, say VA1, or we'll write VC1. Afterwards, it lose contact. Spring is relaxed, no? This is very important. Keep it here like this. So there's a block A. And what it will do, it will go and compress this particular thing. What is the state of block B? It is at rest, rest, rest. What happened to A1? This will continuously try to move. Now this will go and will, the moment it goes, the block C will goes and strike the spring. Spring what happened will get compressed. Due to compressive force, due to compression, spring force will act on this towards left, spring force will act on towards right, and both will have maximum compression. Let's analyze what all can happen so that we can conclude here. So this will continue to move. This will go and strike. Maximum compression occurs. I needed to show all striking, then that one, or one diagram. We'll put it. Where they'll be in compression. What will happen to velocity of the block? This will start decreasing, and this will be increasing. VB2, let me write it. VC will. So this will be under compression, no? KX, KX2, I'll write it. Then maximum compression will occur. Both will have common velocity. Because we are just searching what will happen. Both will have common velocity. Then again at one particular point, and what particular point maximum compression it is. So XM maximum compression. Then afterwards, it will start coming out of there's a compression, maximum again compression. Then again natural length will come. Close. Okay, now you say this. Okay, let's get into the maximum compression. Here only compression. Some X3, I'll write it. KX3, KX3. This will have velocity, say like a VB3. This will have velocity VC3. It's a compression still. Then at one position, they will have natural length. At one position, it will acquire natural length. Spring is relaxed. By this time, this will acquire some velocity, VB. This will acquire some velocity, VC. Then they will lose contact. This is the final condition that is taking place. So what is our question? Our question asked about finally. You can really, this problem, you can solve without drawing all these diagrams also. He's asking that find the speeds eventually acquired by A and B. The question is about testing your basic fundamentals, nothing to do with any concept. The diagram speaks a lot. So how you apply all the things, this one, this is the final. Okay, no. So what is the only condition available? M very much less than capital M. Uh, is this correct, first of all? Anybody? So this is what happens, or some other thing happens? Or is it only one time the block will come in contact with the block B? Or now only after this again, this will never come here? Unless you don't think this, say, this is what naturally we'll try to think. Oh, okay, this what. But try to take help of this from the beginning only. Yeah? Then only you'll be on safer side. Otherwise, gone. You cannot think just plain way like this here. You should think from the beginning. This M will be very much less than M. The moment I release, tell me which will have more velocity. VC1 will be very much greater than VA1. Any reason? This is thing. So your question should actually, this condition, if you start thinking in the end, no, then gone. It should be brought in the beginning only. So what is the basic idea? M is very much less than capital M. So therefore, VC1 will be very much greater than VA1. If you don't analyze this and just keep on draw diagram, you'll become artist. You'll not become engineer. Okay, like your teacher is showing diagrams. No? Anybody can draw. What is there in this one? We have to take that help of that condition. So VC1 will be very much greater. So this VA1 will be very less. So this will go now collide with this. Again, as VC1 is very much greater, it will impart some momentum. It will impart some momentum. Then it will return back. It will go and collide. Like that, the block, see what happened, will have n number of collisions. And finally, it come to rest. Since masses are same, they must have same velocity. I think the idea of the problem is like this. Huh? Actually, VC1 very much greater. Of course, so this will moving with a less speed. This will go collide. Again, will return back. It cannot be like this. Huh? It will be like this. Because this is a lighter mass. It will rebound. It is having very much high velocity. Again, will come and collide. Again, the sequence will be like that. The block, see what will happen continuously. Sequence will collide with first with B, then A, then B, then A. Finally, it will come to rest. Since what is the net force acting on system? Zero. Momentum should be the initial momentum zero. Final momentum should be zero. So therefore, they must have same velocity. So what actually happens? This is one sequence like that. This will go collide. In fact, this VC should be towards left. It should not be shown like this. I'll just put it. It is such a way that it will be. This will go and collide. This VC will be very much greater than VA. So VC3, I think we have VC3 only. Let me keep it. VC3 will be very much greater than. Let me have this one. So this will be VB3. Will be very much greater than VA1. VC3 will be very much greater than VB3. Again, it'll go and collapse. Like this, the sequence will occur, and finally, what we get is C will be at rest. Somewhere, we don't know. Okay, no. Why they must have same speed? VA equal to VB. Why they must have same speed? Conservation of
Momentum.
momentum. Momentum conservation. So therefore, first I'll apply conservation of mechanical energy. Okay, getting this one. I think the mathematics, what is very important, that very much less than. Without that, okay, whatever we want, we'll think it. So can be asked for you the spring blocks. it can be anything. So you can't just generalize anything on spring blocks. Some basic things are there. Okay, remember it. So you can do one thing. So this you find very difficult to really understand this condition. You assume this say like a 10 kg, let this be like a say 0. Or 0.1 kg. Check the condition, then it'll be very easy for you. Even here also with a very small mass, it comes and collides with this. Then look at the condition. From that, what happened? From that, what happened? We can manage things very easily. Okay, no. So we'll end up the class tomorrow. We'll have some other problems I'll bring for discussion. Okay, thank you, all of you.